All right, here we go with some ACT practice problems. I've got numbers 19 through 24 here, and let's see how that goes. In number 19, we've got 2 points, point R and S, and they're asking us about the distance between them, but they don't actually give us coordinates. But we're still going to use the distance formula that we learned in class. So we're going to take x2 minus x1 and square it, and then y2 minus y1 and square it, and all of that is under the square root. So it's just a little strange here because our x2 is really x plus 1. x2 minus x1. And then I'm going to take my y2, which is y plus 1, and subtract my y1. So look what happens here. If I combine like terms in these parentheses, x minus x is 0. So I just have a 1 left over. And same thing here, y minus y is 0. So I just have a 1 left over. So 1 squared plus 1 squared, well, that's 1 plus 1 is 2. So my final answer is the square root of 2. That's an example of an ACT problem that looks really complicated, but then when you actually go to work it out, it's not so bad. Number 20, Will is standing 40 yards due north of the point P. So I'm going to go ahead and 40 yards due north. Looks like that. Grace is standing 60 yards due west. Okay, and even though this is 60, it's a little bit shorter because I'm running out of room on the paper. So that's in the westerly direction. And what's the shortest distance between Will and Grace? So this is a way for them to ask you a Pythagorean theorem problem or a right triangle problem. So I am going to set up my Pythagorean theorem, which I can use any time I have a right triangle and I'm looking for a missing length. So I'm going to go a squared plus b squared equals c squared. So 40 squared is 1600 and 60 squared is 3600. So let me get my calculator out. So that's 5200. So 5200 is c squared. So when I square root both sides to find what c is, and I do the square root of 5200, I get a decimal. And the decimal I get is 72.111. And then we look back at our choices and we see that our answers are not in decimal form, they're in simplest radical form. So if you don't know how to simplify a radical, you could, first of all, you can go through and you can get rid of E and A because neither one of those is 72.111. And then you can punch in these different values and you can see which one is equal to 72.111. So I'm going to do 20 times the square root of 13, and that works out to be 72.111. But I did want to show you guys how to simplify a radical. The square root of 5200, I can rewrite that. I'm going to do a factor tree on 5200, and that's 52 times 100. And 52 is 4 times 13. So what happens, I've got a couple of perfect squares here. I'm not going to prime factor it all the way down. I'm just going to rewrite the square root of 5200 as the square root of 4 times the square root of 100 times the square root of 13. And the square root of 4 is 2, and the square root of 100 is 10, and the square root of 13 is a messy decimal, so I'm going to leave that one. So 2 times 10 is 20, and that's how you simplify a radical. So that's how we know B is the right answer. Number 21, we've got, we don't have any multiple choice here for number 21, so let's see. I'm looking for my answer key to see if that's a mistake or if we just need to work it out. Nope, we just need to work it out. So we are going to label our picture The circle is inscribed in a square with a perimeter of 20 inches. So we know we've got a square and all the sides are the same. If the perimeter is 20 and they're all four the same, I can do 20 divided by 4, and that tells me that each side is 5 units long. Then we know this is a circle. So if the diameter of my circle is 5 units, then the radius of my circle is 2.5 units. So we're looking for the area of the shaded region. So I'm going to find the area of the square, and I'm going to subtract the area of the circle. So the area of the square is 5 times 5, or 25. And then the area of the circle, remember, area of a circle is pi r squared. So I'm going to go minus pi times 2.5 squared. And I'm going to put that 2.5 in my calculator, and I'm going to get 6.25 pi. And this is actually given as the correct answer to the problem. And on the ACT, you could expect to see things in terms of pi, so that means they don't multiply the pi out. But if you did go through and multiply it out, you would get the decimal answer, which is 5.37. Number 22, a trapezoidal flower garden is shown below. What is the area? And this is just a question of, do you know the formula for the area of a trapezoid, and do you know the parts of a trapezoid? So every trapezoid is made out of 2 parallel sides. Most of the time they show them on the top and bottom, but in this case they're on the left and right. So these are called our bases. Those are the bases of a trapezoid. Then every trapezoid has a height, and that height is at a right angle between the bases. So in this case, our height is 13. So what we have to do is to add the 2 bases together, and then we're going to cut that number in half. And that's going to sort of give me an average length, is how you could think of it. And then you're going to take all that business and you're going to multiply it times the height. So we're going to add our bases together, 9 plus 10, cut it in half, and then multiply all that times 13. So 19 divided by 2 is 9.5, and times 13, and we get 123.5, 123.5 meters, square meters. In number 23, we're looking for our missing x. So we're going to use some of our skills that we've already learned in geometry for this one. I've got y plus 30, all of those together equal, so those are complementary, so that must mean this missing y is a 60 right here. And then I've got a straight line with x and y in it, and so a straight line, remember, is 180. So I could take away that 60 and I get 120. So number 23 is E. And last but not least, number 24, we've got some parallel lines cut by a transversal. And so they're asking us what are congruent and what are supplementary. So let's take a look. W and A, those are corresponding. We know correspondings are congruent, so that's going to be a true statement. Then y plus b. Y and b, what's the relationship there? They are same side interior, and we know the rule of same side interiors is that they add up to 180. So that one's going to be true. And then last but not least, let's take a look at x and d. X and D are alternate exterior, and the thing we know about alternate exteriors is that they are congruent. They don't add up to 180 like number 3 says. So I'm looking for the choice that says 1 and 2 only, and that's going to be choice C. Thanks for watching, and I'll post another video here in a little bit with the rest of the ACT problems.